Hey, 12th graders. So we are finishing up our 13.2 notes, and our 13.2 notes are dealing around this idea of tangents and normals. And so we practiced last time, we learned about last time the relationship between the normal and the tangent. And I would like for you to tell me right now what is the relationship between a normal line and the tangent line. So remember that your normal line and your tangent line have a relationship that they go through the same point that is on the graph, where the point where the line is tangent. And so they both go through that same point, and also they are perpendicular to each other, right? They cross at a 90-degree angle. So we practice the idea of making a tangent line. So when we have the slope of the tangent line, which is what your derivative is, and we have the point that it goes through, then we have all the information we need in order to make an equation of a line. So we learned how to make the equation of a tangent line, and then we said, okay, well, then the normal would just be the negative reciprocal slope that goes through the same point. And so we can also then just very quickly make the equation of the normal line. So we tried it with something that's, of course, as we typically start out with, a little bit more straightforward, a little bit more simple. Some might even dare to say easy. Then we moved on to something that's a little bit more like what we're used to seeing, which is a little bit more of a word problem, a real world application, a little bit harder. Because of that, we said, okay, we've got these straight segments and then a parabola that attaches them. We're going to use some information that we know about in terms of derivatives in order to piece together this equation, making systems of equations. It was tough. We are now going to talk a little bit more. We're going to circle back to normals and tangents, and this one is tough. We are only spending our entire notes today talking about this example. So I would imagine our notes are not going to be super long tonight, but I would imagine that you're going to get to the end of the notes and be like, what just happened? And so maybe explore the idea of potentially rewatching this video and redoing this problem, maybe twice, or like going through it once and then going through it again and retrying it, maybe reprinting off the notes or do it on a separate piece of paper and be like, okay, do I understand the thought process of why this happened? Why did we go from this step to this step? From this step to this step? What words led me through those steps? So never be afraid of going through the exact same problems multiple times, and then just go through it with a different eye of like, okay, do I understand each step that's going to happen with each process that we're going through in the notes the first time? And then the second time, do I understand what led me to know to use that step, right? That's the hardest part sometimes. Okay, so we have this equation. Do we know how to find the derivative of this equation? No, we do not. But we do know how to graph the derivative of this equation using our fancy calculator and derive, or the little derive button guy that's right over here. Okay. So we have this equation and it says find the equation of two vertical lines that are normal to h. So the key word here, hopefully you would highlight or underline and you're like, oh, normal. Okay, well, normal is perpendicular to tangent. So we're kind of moving backwards through this maze of this problem, and we're saying, okay, normal. Normal means perpendicular to tangent. Okay, so what else is going on in this problem that tells me which tangent I want to be normal to? And it says we want a vertical line. Two, but let's just focus on one right now. A vertical line that is normal to that. So a vertical line that is perpendicular to the tangent. So if the normal is vertical, then your tangent must be what? If your normal is vertical, then your tangent must be horizontal. So using those backwards pieces, bringing all of these pieces together and saying, okay, well, I know that my normal is perpendicular to the tangent. And if my normal is vertical, then my tangent must be horizontal. So we're going to ask ourselves, first of all, where is the tangent not vertical, but instead horizontal? Okay, so let's just go through and first find out where is the tangent horizontal. First things first, we should graph this guy on our calculator if you haven't already. And then second, we will probably want to graph our derivative. Oh, no. Don't forget to put your entire numerator in a parentheses and your entire denominator in parentheses, or you can press Control Divide and it creates a fraction for you already. So this is what our graph looks like. I know that we have it on the screen, but I find that it is really helpful to have a physical graph on the page that you can kind of like draw and put labels that you know of and kind of physically understand it. So I would really encourage you to just kind of quickly sketch this graph. It doesn't need to be perfect. So if you feel like you're somebody who tends to try and perfect things, that maybe your tests take a little bit too long because of that, I would encourage you to start letting go of perfection in some ways and just trying to learn how to quickly sketch. Okay, so the idea of where would the tangent be horizontal is typically where your maximum or where your minimum is. So we can have a general idea of like, okay, we will probably have a maximum somewhere around here where it's the very, very tippy top of that guy right there. And then we'll have a minimum up here where it's the very bottom of this part of the graph, right? So we have two places where our tangent will be horizontal. Let's put that in a different color. Which then circling back to the question, which the question asks, where find the two vertical lines that are normal in a vertical that are normal to the graph. Makes sense that okay, if I have two tangent lines that are horizontal, then I'll probably have two normal lines that are vertical. So we can call those the tangent lines in blue. So then the idea is that your normal lines would go through that same point. Who knows if it's there or there, but we'll see. And just be vertical instead because it's perpendicular to your tangent line. Okay. So this idea of, okay, well, what does it mean to be normal? And then what does it mean to be a vertical normal line? And connecting all those pieces together and understanding how it squishes together. Squishes? I don't know, but pieces together. All right. So we need to find out where would the tangent be horizontal. Well, the tangent would be horizontal where there's a maximum here and a minimum here. You could use your maximum minimum on your calculator to find that, or you could also do your derivative graph and figure out where your derivative crosses the x-axis. So this is where your derivative crosses the x-axis, and this is where your derivative crosses the x-axis. We can show that derivative. Maybe I'll do it in red. Our derivative would look like that, and then like that. Positive slope above the x-axis. positive slope above the x-axis. And then this is where it would be a negative slope, so below the x-axis. These are the x values where your tangent would be horizontal. So ways to show that, because remember that the IB is grading you on, can you show how you would use calculus in order to solve these problems, right? So the way to show that would be like, okay, well, I know that the tangent is horizontal when my derivative is equal to 0. And then just say, okay, x equals this when the derivative is equal to 0. You can trace on that guy. And it's, when x is equal to -1 and when x is equal to let's jump over to 3 just so I can skip this guy, and 4. Realize that your trace can get you to those key values as well as maximums and minimums. Realize if I scroll up, it automatically jumps to the minimum. If I was scrolling around over here, it automatically jumps to the minimum. Okay. So these are the x values when the derivative is equal to 0. They also happen to be the equation of the line. Because remember that vertical lines have an equation of x equals a number, right? Well, that number is x equals -1 and x equals 4. That would be the equation of the normal line that is vertical. So your answer is x equals -1 and x equals 4 as equations, not necessarily as values, but as equations, vertical lines. Okay, so recapping. When we saw normal, we were like, oh, okay, normal is perpendicular to tangent. So we want a normal that is vertical. Perpendicular to vertical would be horizontal. So that means that we want a tangent that is horizontal. So see now how it's this like convoluted process that's bringing us right back to what we've started this entire calculus section of our IB diploma on, of just really zoning in on horizontal lines when derivatives equal 0, finding a different way to get you to that idea.